Hello and welcome back to our next session of Matlab programming. In this part, we're going to learn one of the most important functions in math and also Matlab programming. And it's going to be trigonometric functions. They're huge, they're everywhere. And as an engineer, you're required to have a very thorough understanding of the sine, cosine, and trigonometric functions in general, and kind of know how to use them in your projects and programming. The good point about trigonometric functions in Matlab is that it's really easy to use them because we literally type them the same way as we call them. To give you an example, if you want to find the sine of 30, so I can easily find it. Cosine, the same thing. Tangent, the same thing, and cotangent. And these are the basic ones, and there are a lot that I'm going to cover. But to start with, these are the four ones that we use a lot. There is something very important when using trigonometric functions in Matlab, and I cannot emphasize this one enough. It is often the main reason why people have unexpected results using trigonometric functions in Matlab. Let me tell you this way. When I want to find, let's say, sine of 45, Matlab by default interprets anything inside the parentheses as radians and not degrees. So this is not sine of 45 degrees, it is sine of 45 radians. If you want to change that to sine of 45 degrees, you need to convert the degree to radians. Because remember that Matlab always, when it comes to trigonometric functions, it always requires that the parameters inside the parentheses should be in radians measured. Before doing that, let me just recap the formulas that we use for converting the radians into degrees and vice versa, because they're important for this session. You already know them, but it's good just to review them here. Now I'm going to convert radians to degrees. Okay, and we learned that if you put a percent sign in front of any line in Matlab, it's going to be interpreted as a comment. Here we go. Degrees equals radians multiplied by 180 divided by pi. And radians, on the other hand, equals degrees multiplied by pi over 180. Okay, so these two formulas are the ones that we use for converting any number into radians and vice versa. If we repeat that, 45, you see that it's interpreted as radians. So sine of 45 radians is this, but sine of 45, and now I want to convert degrees because now I want to find sine of 45 degrees. So what I do have here is degrees here. I do have this. And if I multiply this one to pi over 180, the result of the whole thing is going to be in radians, that something which I need. So 45 multiplied by pi over 180 is going to be this one. And if you remember, the sine of 45 is going to be square root of 2 divided by 2. Let's do that just to test our results. SQRT of 2 divided by 2, which happens to be the sine of 45 degrees, is going to be the same as what we found here. So it is really important that we understand this concept. This is a very simple concept, but it happens a lot that while you're doing programming, so you're thinking about a lot of stuff, a lot of parameters you want to do, how you want to define it, and it's really easy to forget about converting degrees to radians and vice versa. And you might kind of think that, okay, sine of 45, but it's not 45 degrees in radians, and you get a result which is either unexpected or different from what you should get, but in worst case, you don't realize it because it's a number and it's really hard to find out that it's a valid one or not unless you use some specific techniques. So it's better to prevent that kind of mistakes here. And I want you to just investigate different numbers and functions here so you kind of be confident using Matlab while calculating trigonometric functions. With that said, let's explore more in trigonometric functions. One important thing that we need to remember in Matlab is how to do the inverse. In this part, we're going to learn how to do the inverse of trigonometric functions. So we learned the sine of 43, for example, is going to be this one. But when we want to find the inverse of sine, can we do sine of, let's say, negative 1, 45? No, we cannot do that. The way that we're going to do the inverse function is through using arcsine or arccosine or arctangent. And the way that we're going to do it is using a in front of the trigonometric functions, and it converts them into the inverse format. If I say a sine of, let's say, this, and it's going to be this number, or a sine of let's go with cosine of this one, and you do realize that it cannot be more than 1, right? This one cannot be more than 1. For real numbers, of course, we can go with like a sine of like this one, but it's going to be complex, so we're going to cover later. Here we learned how to use the inverse format of trigonometric functions. Again, the important point here is that exactly like the trigonometric functions that we learn, Matlab is going to receive in radians and produce the result in radians too. So in case of a sine, let's go with a cosine. A cosine of a number, this number also is going to be in radians, and the result also is going to be the radians. It's really important, as you can see, when we use these trigonometric functions, all we do is dealing with radians, and we're going to convert these radians into degrees. For instance, the last one that we find, a cosine of this number is going to be this, and if I type ans, multiply, now it's in radians, okay? In order to find the degrees, we multiply this radians by 180 divided by pi. If I do that, this is going to be the 53.1301 degrees. Now it is in degrees because I converted the result into degrees, converted the radians. It's kind of important that we understand it here. Let's do an example. If I say a sine of 0.707, okay, so the a sine is going to be this number. Now, if I come and convert the answer multiplied by 180 divided by pi, and as you can see, it's near 45 degrees because I couldn't just make this one a complete number, but I wanted to find the 45. So, if you remember, the sine of 45 degrees is going to be pi over 180. So now it is sine of, what we're going to calculate here is sine of 45 degrees here in this line. 45 degrees is going to be this number. Okay. Now if I reflect back this number, the answer, into a sine, so a sine of answer is going to be this number, and now I convert this one into degrees. So answer into degrees, and you kind of see that now it's a perfect 45 degrees. So I encourage you to work with these conversions, and it's really important that we kind of grasp the idea how we can convert the numbers and radians together. And as you see, we used it for not only the sine functions, but also their inverses as well.